So hi, I'm Rotem Gutman. I'm the PI for the automated Cyber-Readiness Evaluator project. So the core challenge that we're looking at here is the fact that DoD has to staff up to over 6,000 seats in cyber operator roles. All of these personnel have to be certified as mission ready. You have to be able to do that in a way that's scalable, objective, reliable, that we can prove the validity of. And one of the issues that we have right now is, in order to get pre-qualified for the role, I go out and get a couple of professional certifications. Well, that would be helpful if those certifications had been developed for the specific role that I'm going towards, but these are industry certifications. So in order to shore up this, this requirement, we end up having to do individual assessments. Essentially, there's a standard, there's requirements of knowledge, skills, and abilities you have to have, and somebody ends up standing over your shoulder and saying, okay, do this, watching them do it, and then going through individually, one-on-one, and it just doesn't scale to that size of a need, especially as a continuing need. So the solution, develop an automated system that can evaluate for mission readiness of your cyber operators. So the system, essentially, we always say train as you fight. Well, let's evaluate as you fight. The idea is put the cyber operator in a scenario that's similar to their normal work scenario. Only we'll design the scenario so that in order to succeed, they have to exercise all of those knowledges, skills, and abilities that are required, that are in the standard. Then we let them do the tasks in an environment that mimics their real world environment and understand what they're doing as they're doing it in an automated fashion. Then verify whether they're mission ready or not, and if they're not, what are the deficiencies? What didn't they do that they needed to accomplish? And then based on that, we get a lot of benefits from that. Essentially, first of all, the automated analysis. When we can do this in an automated fashion, that means that I don't have to assign personnel one-on-one to each individual case. I can say, here's your login for the evaluation system, go do your evaluation, and I as a commanding officer, I'll get an email with here's how he stands, or any other way of delivering that report. We can isolate what are the specific deficiencies, not just, this guy really doesn't seem like he can do his job, but specifically, what can't he do? Where does he need additional training? Where can we shore that up? Generating automated remediation plans. Once we know what the deficiencies are, we can sign them up for additional training on those topics. And additionally, by capturing the data, we then have that data available for future reviews. Let's go back and look at that data 2 years, 5 years down the line, once we have job performance metrics, and say, what are really the differences between your high performers and your low performers when we first looked at them? And then can we isolate who they're going to be ahead of time? So how do we do this? Well, there's several things that we had to do. The first thing is we have a capability in-house, the Step Forward platform, that lets us actually push out an entire virtualized environment, be it from one workstation to a cyber flag size environment, thousands of machines, hundreds of participants, and anything in between. So leveraging that, we created our evaluation scenarios in that environment, and then we had to add the capability to actually record their activity. So this takes place as both a video feed of essentially the video feed that we're pushing out to them of everything that they're doing. This is how they're looking into the environment. That's how we're recording it, as well as other sensors in the environment, such as keyloggers and so forth. Once we have that data, especially the video feed, we have to analyze that. That's not easy to parse. So we've developed a computer vision system that can actually look at that video feed and by going through the video feed, detect, okay, what am I seeing on the screen? What's going on right now? And this detects, various GUI elements, various tools that are being used. Once we have that output, we have an evaluation system. The evaluation system has 2 layers. So the first thing it does is it takes the output from the video analysis engine, the ACE Vision as we call it, and takes that output along with output from other sensors in the environment, like the aforementioned keylogger, and creates essentially a list of what's actually going on. What actions is he doing? Right now, he's opening this file. Right now, he's using this tool, or he's going through the registry. Whatever the case may be, what is going on and when. Then the second layer of that transitions, relates the actions that he took in the environment to what knowledges, skills, and abilities they represent. If he's carving out, the PDF files, then he has knowledge of file carving tools and so forth. Finally, we generate the ACE skill report. This is the end result that the commanding officer wants to see. Is he mission ready? If he's not, why not? So to go into a little more detail of how we implement this. So the first thing that we did is we chose the forensic analyst role as the first role that we wanted to implement for the simple reason Forensic analyst can do his job on one workstation. Less back-end material for us to have to create for this. Here's a forensics workstation. Here's some captured material. Get us the actionable intel that you can. Additionally, they can be reasonably expected to do their job, exercise all these knowledges and skills in a reasonably short time frame. And we developed this based on the actual JCT and CS requirements for that job role. So the first thing that we did is we developed the scenario sort of in reverse. So start with the requirements. What knowledge, skills, and abilities does he have? And then build the scenario so that he has to exercise as many of those as possible in order to be successful. This is different than telling him, okay, I need to know that you have knowledge of file carving tools. Go carve out all the files. Well, that doesn't give me the same information as me knowing that when he's out in the field and he sees registry entries connected to a certain file and he goes and looks through the file system and there's no references to it anymore, that he'll then go and carve out files of that type. But by putting him in an environment where we just tell him, look, get me the intel that I need, and all the indicators are there, and he actually goes and does that, now I know that this knowledge is, he can operationalize this knowledge. The second scenario that we did, the first scenario, sorry, was a missing persons case, where we actually had, there's a person of interest, we went to his place of residence, it was trashed, we recovered a damaged hard drive, get us the intel you can. The second scenario, we had classified, not actual classified documents, but for the case of the scenario, classified documents that we know they're in enemy hands, we don't know how they got out there, we believe they leaked from a defense contractor, so here's the defense contractor's network, here's a machine from it that we captured, find out what happened. And this has multiple layers to the story, indicators of APT1 possible activity, physical devices that probably should have never been connected to this machine, accessing personal email from it on the public internet, various things that go on. And some of these are red herrings and some of these are relevant. But a good forensic examiner should be able to look through this and determine what the story is, what came out of this. So the next thing that we needed is the capability to actually capture that data. So as I mentioned, this is the Step Forward platform. We built it in the platform and we added capabilities to the platform that let us do both foreground recording started by a participant or background recording. So if you log into an evaluation scenario and your account is marked, this person needs to be evaluated, we can record everything that you do. But it's important to note that this recording is done on the server in such a way where we can't accidentally capture stuff on your desktop, passwords, things that you were doing in other windows, and even cut and paste is disabled into the environment from your environment, just because we don't want to accidentally capture anything that's not relevant to us, and that's also good for our customers to not worry that they might be leaking information out. The next part is, we had to actually do this data collection. So we started with CERT staff. These are people that have these forensic skills, and usually at a pretty high level, which is good for us for training the vision system on what the tools look like when they're used correctly, but really more interesting to us is people that might not be great forensic examiners, that might have these deficiencies. So we continued and we actually integrated with CMU's graduate students. There's forensics capstones. These are students that have taken several courses on doing data forensics, and now as part of a capstone, they actually have to do this analysis. They get given this scenario, sit down and do their best, and you get a much broader variety of skill sets from people that, they might be rich and ready today, to people that really probably weren't paying attention in some of those lectures, and it gives us a much more useful variety. We have a pilot program with DoD personnel that will be kicking off next month, as well as planned integration with CMU's Information Security Office as actually making this part of their regular professional development requirements. So the next thing that we had to do is, now that we have these videos, we have to be able to analyze them. This is where we collaborated with Professor Yasser Sheikh of the CMU Robotics Institute's graphics lab. So him and his grad students worked with us to develop a vision engine that can actually parse through this video and frame by frame go through and detect, okay, what's going on, what's happening on the screen. To give this example, here they've captured a drive, and one of the requirements is to verify the state of the evidence. Well, there's this MD5 value on screen that he's generated through using this, using autopsy, and we need to know that he's generated that he's verified that value is the same as what we've provided with him. So the vision system, looking at this particular frame, this is a representation of the internal state of the memory as it's looking through the results of processing that particular frame. And if you look carefully here, you can see there's one red dot that's much brighter than the rest of the sort of background noise. This corresponds to this position on screen, essentially saying, look, I've found a match to that template. And we have templates for various GUI elements, for things that are essentially anything that would be important for tracking as part of the scenario, be it the cursor position, GUI elements, menu options, shell commands, etc. That gives us an output, something like this, that is essentially a series of timestamps and activities. So what you're seeing here in the middle column is essentially what would be output by the first layer of the evaluation system. After it got these raw reports of, here's the stuff I saw on screen, and then now here's what that represented as far as actions. A better way of viewing this, so this video is not something that we normally output from the system, but what you're seeing is that everything above the black bar on the bottom is an actual raw capture of data that we collected when we did one of these collections. Everything below it is what the activities are that are going on there, as would be output from this first layer of the evaluation system, basically saying, here's what he did on the screen at that time. This would be output as a big CSV file for the entire length of the scenario. We just took the entries from that CSV file and essentially put it as subtitles for demonstration purposes. So as I mentioned, this evaluation module is being developed in collaboration with Professor Jeff Gordon at CMU's Machine Learning Department, along with several of his graduate students. And what we're finding is actually the right way to evaluate different activities varies depending on what the activity is. So some things are simple. You know, if I see that MD5 value was generated, he probably verified the state of the evidence. Whereas other things, such as the file carving, I want to see that he went to the registry, that he saw the entries that would cause him to want to look at this. Then he tried to recover it from the file system, wasn't able to. And those take a little bit more complex methods. And so by using a hybrid solution, we're getting much better results. These results are actually from the vision system, and they're extremely encouraging. The things that make computer vision hard are not present in our use case, which is what makes it so uniquely suited. We don't have occlusions, we don't have shadows, we don't have lighting, we don't have perspective. All of these go away. It's going to be rendered the same time every time. The environment that they're using, we control. So we set the fonts, the themes, everything is under our control. So when we capture that data of this is what this icon is going to look like when he uses this application, it's going to look exactly like that the next time as well. As far as expected outcomes from this work, as automated assessment of individuals, we're already starting a pilot program to actually do that, to show that with actual DoD personnel that we can essentially replace their current evaluators and give the same results or better results as their evaluators. We'd like to extend this to additional roles beyond the forensics examiner. Throughout the entire development, we've always kept in mind, we want to make everything that we do generalizable. We want to hit, infrastructure support, incident responder, whatever the case may be, we want to support analyzing their mission readiness without having to start from square one. Just take whatever tools we haven't already built in the knowledge of, add those tools in, whatever's unique to their role, and then do the mappings to their knowledge, skills, and abilities. Clearly, this saves a lot of time and money, both in personnel as well as the resources that they have to commit, because we can push out this environment anywhere in the world through the use of the Step Forward platform, do the data collection, process it, and then send back a mission readiness report, the ACE skill report of how your personnel are. Finally, next steps, we're actually continuing as a line project for 2015. We're continuing this DoD pilot program, and we want to extend that to additional services and hopefully get it to the point where we can just certify any mission role, any role that's necessary, as well as extend this into actually evaluating groups. We're actually collaborating, we're joining together Jennifer's work with our work so that we can actually move forward into taking entire groups, put a CPT into an environment, make them do their job, evaluate them on how they do their job, and then certify, this is what they can do, this is how they can do it. Or alternatively, here's what they missed, here's what they didn't do, and here's additional training that they might need. So collaborations are welcome. One of the things that we made sure of as we developed the system is each one of those pieces can operate independently. You might have research that you want to do where, okay, I don't really care about mapping knowledges, skills, and abilities, that's kind of your thing, but I'd really like to be able to put users in an environment and get a text representation of here's the things that they did in that environment. That's really useful to me. Well, great, here, take these elements of it, run them on their own, and then you do your research on the output of that. We want to make the tools that we generate be useful for additional research in additional domains, be it insider threat. I want to put the system and track what somebody's doing, or various human-computer interaction, whatever the case may be. We want to make that available as soon as possible. And so we're always designing with making with the idea of generalizability in mind. If anybody has any questions or would like to contact me, that's my email address. I'm always happy to collaborate on this material. That's it.